Hello everyone. We are going to practice writing electron configurations and filling in the orbital diagram for the electrons in an atom. So the first example that we are going to do is iron, which has atomic number 26 and it has 26 electrons. So let's fill these 26 electrons in that orbital diagram, right? So starting with 1s, right, the energy is increasing this way. You need to memorize the order of the energy levels and the orbitals in which they are filled. 1s being the lowest energy level, and we have to follow Aufbau's principle, meaning we cannot fill a higher energy level or place an electron in a higher energy level before filling the lower energy level. Then Hund's rule is when you are placing electrons in a p sublevel or in a d sublevel or in an f sublevel, make sure that each orbital is singly filled first, then we pair, right? And Pauli's exclusion principle states that when we are putting electrons in the same orbital, they have to have opposite spin. So let's start and fill the orbital diagram for iron atom, which has 26 electrons. So the first electron goes in 1s, the lowest energy level, and the other electron goes with spin down. So 2, then 3, 4. I already filled 1s and 2s. Now we are going up to 2p, which has higher energy than 1s and 2s. So we have 4 electrons, then 5, 6, 7. Fill each p orbital singly, right? And then start pairing. So we had 4, 5, 6, 7, 8, 9, 10, then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Then after 4s we fill the 3d orbital, right? So that is going to be, we already placed 20 electrons, so 21, 22, 23, 24 and 25. Now the 26th electron, so once all the orbitals are singly filled, so this is 3d, right? All the 3d orbitals are singly filled. Now the 26th electron will go to d1 with an opposite spin, right? So if I write the configuration, what will be the configuration of iron? So we start with 1s. So this would be 1s2, then 2s2, then 2p6, then 3s2, then 3p6, 4s2, and then there are 6 electrons in the d orbital, right? So it should be 3d6. So this is how we place the electrons in an orbital diagram. Okay, so now let's do another example. Let's do bromine. Bromine has 35 electrons. So place the first electron in 1s, the second electron with an opposite spin. So 2, 3, 4, Now we are entering the p orbitals. 5, 6, 7. Start pairing 8, 9, 10. Then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Start pairing 26, 27, 28, 29, 30. Then in the p orbitals 31, 32, 33, 34, 35, and this is what the number of electrons in bromine is, right? So now let's write down the condensed form of the electron configuration. So 1s is full, so we'll start with 1s. There are 2 electrons in 1s, so 1s2. Then we have 2s2, then 2p6, then we have 3s2, then after 3s we fill 3p, so we have 3p6, then 4s2. After 4s, the d orbitals, 3d orbital is full, so 3d10, and then last thing is 4p5. So this is the electron configuration of bromine, right? And it has 1 unpaired electron. Now look, the last energy level is 4p, right? 4 in 4p we have 2 paired and 1 electron does not have the pair. So it has 1 unpaired electron. So bromine has 1 unpaired electron. We'll need to know this when we are doing the ions. Okay. So for now you can just count how many electrons are not paired, and that is what we need to know. Okay. So that is all, and hope that video is helpful. Thank you.